Okay, section 7.4. Our next section, what we are going to do is we're going to talk about the process by which we are going to add and subtract radicals. And I'm going to take you way back to introductory algebra. Okay, I'm going to take you back to the beginning of high school, and you saw something like this, and your teacher hopefully did a good job explaining how to do this. If we have 9x plus 5x, when we see those algebraically, what do we call those? Anyone remember? They're like terms. Yeah, they have the same variable part, so they're like terms. What can we do with like terms? We can add them. Okay, it's just like counting oranges or apples. I've got 9 of something here, plus 5 more of that same thing. That means I have 14 of them. Adding like terms. The reason I bring it up is because when I go to add radicals, if I have 9 square root of 3 plus 5 square root of 3. Same problem. 9 square root of 3 plus 5 square root of 3. Because my radical part is exactly the same, these are the like terms. The radical part is exactly the same, they are like terms. So if you have 9 of something, doesn't matter what it is, and you have 5 of the exact same thing, then it becomes 9 plus 5 is 14 square root of 3. You don't do anything to the radical part, you're just counting them up. They're like terms, so square root of 3, square root of 3, so square root of 3, 9 plus 5 is 14, and we're done with that problem. So here's a problem for you. I'd like you to do this. 11 square root of 7 plus 15 square root of 7. Are those like terms? So if I have 11 of these square root of 7s, and I have 15 of the square root of 7s, how many square root of 7s do I have total? 26 square root of 7. Great. Here's the next problem. Let's say that you have 3 square root of 6 minus 11 square root of 6. This time, instead of addition, it's subtraction. That changes almost nothing about the problem. Okay, so again, they're like terms. It's good to identify that first. Well, what's 3 minus 11? 8, negative 8, square root of 6. Great job. So here's a problem where you're going to have to decide which ones are like terms. So if you have 3 square root of 5 plus 4 square root of 2 minus 8 square root of 5 plus 9 square root of 2. Simplify that. Combine your like terms. All right, so I've got my 3 square root of 5 to lead things off. What's the like term with the 3 square root of 5? Yeah, so I'm just going to draw a little arrow here. 3 square root of 5 is like terms with the negative 8 square root of 5. So 3 minus 8 is negative 5 square root of 5. There's your first term. And then the 4 square root of 2 is like terms with the 9 square root of 2. They both have the same radical part. 4 plus 9 is 13 square root of 2. There we go. So the reason I told you that if you could simplify radicals, that's all that you need for this section is the following. So here's the only other thing. As long as you can recognize your like terms, you're good to go. So here is my last problem, and then I've got one for you. Let's say that we have 5 square root of 12 minus 3 square root of 75. Are those like terms? No. But before we give up on the problem, we can think back, and it is possible to simplify radicals if they have a perfect square factor. So I'm going to see if that applies. They might turn out to be like terms. They might not turn out to be like terms. Don't know yet. Okay, so here goes. 12. On the perfect square list, does 12 have a factor that's a perfect square? 4. 12 is 4 times 3. Okay, great. We'll come back to that. Minus 3. Does 75 have a factor on the perfect square list? Yeah, remember, just take that list. It's in your notes, or you can reproduce it real easy and grab your calculator and you just get on the list. Okay, that's all you have to do. And so 75 is 25 times 3, indeed. Okay, so I'm going to use the product rule of radicals again. If you're to the point where you're seeing this and you don't need to write this step down, that's totally great. But I don't want to confound anybody. So I can separate this into square root of 4, square root of 3. I can separate this into square root of 25, square root of 3. And then here we go. What's the square root of 4? 2. Okay, so I'm just going to cross out the 2. What's 2 times the 5? That was already outside the radical. So I got 10 square root of 3. I'm going to pause, so I don't want to lose anybody there. Anyone not see where that 10 came from? It's a legitimate question. No? Okay. Let me write down a little more. Let's try this again. What I'm going to do is, instead of just crossing it out, I'm just going to go through and I'm going to evaluate. So I've got my 5. Square root of 4 is 2, right? And then the square root of 3 I can't do. Then over here, minus 3. What's the square root of 25? Square root of 3. Now, I took the square root of 4. That became 2, right? The 5 was already outside the radical. So now I can multiply these because they're both outside the radical. So now what's 5 times 2? That's where the 10 came from. So the 10 came from there because I had the 5 outside the radical. Then the square root of 4 became 2. Now it's outside the radical. And remember, we only multiply things that are not under a radical with other things not under the radical. We multiply things that are by other things that are. Then over here, what's the number outside of this square root of 3 right here? Negative what? Yes, thank you. Negative 15. Great. And then now they're like terms. So the skill here is what we were doing in the last section. The skill here is simplifying the radicals. Okay, I don't think combining like terms is too big of a deal for any of us, but now we're combining it with that simplifying the radicals. So I have 10 minus 15 is negative 5 square root of 3. So here's your final problem from this section. It's the same sort of thing. You're going to combine your like terms, but you're going to have to simplify before you can do that on this problem. So here you go. 4 square root of 50 plus the square root of 18 minus 2 square root of 98. Let me give you a couple minutes. Grab your calculator. I assure you all of those do simplify. All right, I'm going to get started. If you don't understand where I got a number from, that is definitely an opportunity to ask a question. So for 50, what's the perfect square factor of 50? 25 times 2, fantastic. What's the perfect square factor for 18? 9 times 2. And then 98, what's the perfect square factor for 98? 49 times 2. Yep, just go down that list. Now I'm going to use the product rule of radicals. I'm going to write each of these as their separate elements. So I've got 4 times the square root of 25 times the square root of 2. Then I've got the square root of 9 times the square root of 2. And then minus 2 times the square root of 49 times the square root of 2. Once again, I'm going to write all the steps because I don't want to cause any confusion. If you can leave some of these out, I understand. That's great. So 25 here, I've got 4 times the square root of 25. So that's 4 times 5. And then the square root of 2. Here, there's just square root of 9 is 3. And here I have minus 2 times the square root of 49 times the square root of 2. So it's minus 2 times the square root of 49 becomes 7. So now those numbers that are outside the radical, I can now multiply. So 4 times 5 is 20. And then negative 2 times 7 is negative 14. They're all like terms. They all have square root of 2 as part of them. So that makes this nice and easy to clean up. So 20 plus 3 is 23. 23 minus 14 is 9 and square root of 2. There we go. Any question? So, I mean, it's a harder problem. We're applying something new that we just talked about a few minutes ago to a new problem. I've added in some extra steps. So once you get better at simplifying the radicals, you know, you can leave out these 2 steps right here. You can go right from here to here, but it takes some practice. All right, that's the end of that section right there, 7.4.